In this video, I'm going to take on mastering problem 8.8 about the hippo. So I remember this problem being a pain in the past, but I think it was because if you don't take the right strategy to it, you have more difficulties with it. It seems like I remember the center of mass equation actually being the easier way to solve this particular problem. So what I'm going to do is I'm going to pick the tail of the hippo as the 0 point for our analysis, and that will give me, whenever I find the center of mass of the hippo, which is the same as the center of gravity, I will have the answer in terms of what they want. So this point on the coordinate system is 0.5 meters. This point then will be, where did that mark come from? Let's get rid of that. Goodbye. All right, so anyways, this mark would then be 2.3 meters, and we don't really need the nose of the hippo. Okay, so again, 0, 0.5, and 2.3. Now, let's talk about what this equation means. So what this says is that the sum, that's what sigma means, the sum of each mass times each position plus, just add them all up, however many masses and however many positions. So we're gonna model the hippo as though it is composed of 2 point masses, one having a mass of 0.60, the mass of the hippo, and the other having a mass of 0.40, the mass of the hippo, because that's what 60 and 40% would mean. And since you're dividing the individual masses by the sum of the masses, it actually doesn't matter what the hippo actually weighs or what the mass of the hippo is, just those ratios. So this is going to be, I think it's actually going to be relatively easy approaching it this way. If you try to do it with torque, you can get there too, but the center of mass equation is a lot easier approach to this particular problem. So we know that the 0.40 is at 0.5 meters, and we know that the 0.60 is at 2.3 meters. And all together, 0.40 and 0.60 add up to 1. So let's do some math here. 0.40 times 0.5 is 0.2, and 0.60 times 2.3. Don't feel like doing that one in my head this morning, so let's get out a calculator. That is 1.38. Wait. Yes. And divide that by 1, and that is going to give us 1.58. All right, now let's see, and by the way, since they only gave us 2 significant figures, really what mastering would be looking for would be 1.6 meters as the answer. Does that make sense? Well, so the center of mass, we know it's going to be somewhere in between. 1.6 would be like, let's see, this isn't a scale at all. But yeah, 1.6 would be somewhere here in the middle of the body of the hippo. So yeah, that makes sense. And since we did choose our 0 as the tail of the hippo, that just gives us the answer that mastering was looking for. And I'm going to double check the answer key real quick and make sure that that is indeed. And sure enough, it says that it accepts 1.58 or 1.6 meters.